Integration is the tool we use to measure the area under a curve. Let's start with a simple one. Y equals x squared, from 0 to 2. This region has a curved boundary, so there is no simple rectangle we can just measure. How do we find its exact area? Here's the key idea. Fill the region with thin rectangles. Each one has an easy area, width times height. 4 rectangles give only a rough estimate. But watch what happens as we add more. 8, 16, 32, 64. The gaps shrink, and the total gets closer and closer to the true area. Now zoom in on a single rectangle. Its height is the function value at a sample point, and its width is delta x. So one rectangle contributes f of xi times delta x. Add up all the rectangles, and you get the Riemann sum, an estimate built from tiny pieces. Now let the number of rectangles grow without limit. Each rectangle becomes infinitely thin, and the estimate stops being an estimate. The limit of the Riemann sum is exact, and that limit is what we call the integral, from a to b of f of x dx. Let's read the notation. The integral sign means continuous summation. A is where we start, and b is where we end. F of x is the quantity being accumulated, and dx is the tiny width of each piece. A definite integral measures signed accumulation. Area above the axis counts as positive, and area below counts as negative. For y equals x from -1 to 1, the two triangles cancel exactly, so the integral is 0. Integration has a second meaning, finding an antiderivative. The integral of 2x dx is x squared plus c, and differentiating gives 2x back. The indefinite integral is a family of functions, while the definite integral is a single number. The fundamental theorem of calculus connects the two. If f is an antiderivative of f, then the integral from a to b is simply f of b minus f of a. For x squared from 0 to 2, x cubed over 3, evaluated at the bounds, gives 8/3. Exactly. The same idea appears everywhere. Area, distance, total quantity, mass. Integration means accumulation, adding up infinitely many tiny contributions. So the whole journey in one picture. Tiny pieces become a sum, the sum becomes a limit, and the limit becomes the integral. Integration adds infinitely many tiny contributions, and that is how a curved area gets an exact value.